to the cloud. This is how we go.
Hello. Hello. It happened. Voilà. My coffee is still there. I forgot to put it into the drawer or whatever. The you know the placard. Voilà. Early stream today. Early stream today because I'm busy this tonight. So, voilà. But I'm still doing the tech news real quick. Then I will quickly leave. Up, 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 up. Voilà. Oula. First topic. Um, there are malware in ClawHub. So ClawHub is this skill marketplace for OpenClaw. And it turns out that over the 1,000 or so skills that is present on voilà, over 2,800 skills on ClawHub. So skills are like little markdown files, basically curated system instructions to allow your OpenClaw bot to, do something specific like going on a website or using certain libraries, specific things that you do not want it to search on the web every time, I guess. You can put all that in this in a skill to help the bot do certain tasks. And it turns out that over like there's roughly like more than 10% of the skills on ClawHub that are actually malicious and that have been injected into the hub by malicious actors who performed a supply chain attack. Voilà, so ClawHub is a marketplace designed to make it easy for OpenClaw users to find and install third-party skills. It's an extension to the OpenClaw project, a self-hosted artificial intelligence assistant formerly known as CloudBot and MoldBot. Voilà, 335 skills use fake prerequisites to install an Apple macOS stealer named Atomic Stealer. This activity set has been codenamed ClawHavoc. And I think they are still up, huh? Because it's been fairly recent, like it's a few days ago. But if you go on the ClawHub, and for example, one of the main skill is called Bird that allows you to interact with Twitter. And I think if you search a little bit, you can still find these malicious skills here. At least yesterday night, you could when I saw this. What if I do Bird? So Bird is the official one. Ah, maybe it has been scrubbed yesterday. XAPI. Okay, and yeah, and so basically in this description here, the fake the fake skills required you to go to a random repo and basically download the malware, install the malware, and and as a requirement. So yeah, even though like the skill should have been only um a markdown file. That's what skills are. Hello Nitro, how are you? Hello, China, China, China number one. Maybe they ah no voilà. Did they wait? Install this skill. Visit the web viewer. Aye aye aye. Yeah, I don't think that's how it works. So yeah, bottom line, lots of fake. Be careful if you use ClawHub skills. Basically, I started using AI code. I started using AI to code my little game, but ran out of free cursor tokens. Oh really? Well, I think if you want free tokens right now, Gemini might be like anti-gravity, and Gemini might be the best. Offering you the most free tokens, and also maybe GitHub Copilot might also be quite good at that. So yeah, Cursor right now is pretty limited. Cursor has made its products more expensive lately, so I think you're not going to get a lot of free stuff from them. But and maybe you can. I'm not sure if DeepSeek or or maybe Quen has a free IDE. Probably. So just use Gemini Pro. No, just like anti-gravity. So anti-gravity is the cursor from Google, and they offer you lots of free token in there. Anti-gravity. This lots of free token, and I think there's also like the Quen IDE. I don't remember which one it is. Quen Coder. Um, some like the Quen guys have also an IDE. I don't remember the name, but that might also offer lots of free tokens, I guess. DeepSeek, do they have an IDE? DeepSeek Coder, code language, and no, maybe not DeepSeek. But I'm pretty sure Quen has something free, and Google Anti-Gravity too. I see. I use Cursor with Claude 4.5 because it said it's writing the best code without hallucinating much. Yes, it's true. It's true, but I think you can also use Claude 4.5 with anti-gravity. You can also use Gemini, and they might have larger limits with Gemini than with Claude. But you can also use Claude 4.5 in anti-gravity. If I open it real quick just to show you. So this is anti-gravity, and it's basically a fork of Windsurf, I think, right? So you see here, you can have so Gemini 3 Pro, Flash, Claude Sonnet 4.5, Claude Opus, and even GPT OSS 20B, 120B, if you want. And I think this is all free up to a point, so you can just try that. Yeah. So yeah, bottom line for the ClawHub, be careful if you use OpenClaw and you download Claude skills from ClawHub. And do not and of course the skills in ClawHub, it's obvious, but it needs to be stated. They just need to be markdown files. You don't need to download anything else. So yeah, according to Koi, the malicious skills masquerade as ClawHub typo squats. Yeah. Crypto, of course. Solana wallets, wallet tracker, polymarket bots, YouTube utilities, auto updaters, finance and social media tools, Yahoo, Google Workspace tools, claiming integration with Gmail calendar, Ethereum gas, lost Bitcoin finders. Yeah. And I also saw that there is also a problem with OpenClaw itself that has been potentially fixed a few days ago. But basically, it allowed remote code execution. Just want to read this just to be sure, because I'm probably going to try to install OpenClaw soon. But bon, I was a bit skeptical of the utility. Bon, actually now I have one in mind, so I want to test it. One task for it to do. A high severity security flaw has been disclosed in OpenClaw, formerly referred to as CloudBot, a bot that could allow remote code execution through a crafted malicious link. The issue, which is tracked in CVE score 8.8, not bad, has been addressed in version 2026.1.29, released on January the 30th. It has been described as a token exfiltration vulnerability that leads to full gateway compromise. The control UI trust gateway URL from the query string without validation and auto-connects on load, sending the stored gateway token in the WebSocket connect payload. OpenClaw creator and maintainer Peter Steinberger said in an advisory, clicking a crafted link or visiting a malicious site can send the token to an attacker control server. The attacker can then connect to the victim's local gateway, modify config, sandbox tool policy. I can modify the sandbox configs. Ooh, that sucks. And invoke privileged actions, achieving one-click RCE, remote code execution. OpenClaw is an open source autonomous artificial intelligence personal assistant that runs locally on user devices and integrates with a wide range of messaging platforms. Although initially released in November 2025, the project has gained rapid popularity in recent weeks, with its GitHub repo crossing 149,000 stars. Dang. Given that it went from like a few hundreds to 80,000 stars in like 3 days. Crazy stuff. Mav Levin, founding security researcher at DepthFirst, who is credited with discovering the shortcoming, said it can be exploited to create a one-click RC exploit chain that takes only milliseconds after a victim visits a single malicious web page. The problem is that clicking on the link to that web page is enough to trigger a cross-site WebSocket hijacking attack because OpenClaw server doesn't validate the WebSocket origin header. Wait, so does it mean that OpenClaw with its browser needs to click on the link, or you, the user, on the same machine, need to click the link? I'm a bit confused here. This causes the server to accept requests from any website. So I guess it means that it's the OpenClaw that needs to click on the malicious link, right? Effectively getting around localhost network restrictions. A malicious web page can take advantage of the issue to execute client-side JavaScript on the victim's browser. They can retrieve an authentication token, establish a WebSocket connection to the server, and use the stolen token to bypass authentication and log into the victim local Claw instance. Do you think the AI progress will now stall a little since latest NVIDIA statement? No, I don't think it will stop. I think the latest NVIDIA statement, I guess you are talking about them stopping the GPUs or something, right? Right? This one? Are you talking about this? The NVIDIA stopping the GPUs? Yeah, no stronger GPUs including 7 plus. Yeah. Yeah, so actually, no, it's exactly the reverse of that. AI progress will continue because NVIDIA are not going to ship gaming GPUs. Because here they say that they will not produce any more gaming GPUs, but they're still. But why do they stop producing gaming GPUs? Because they want to produce more data centers GPUs, you know? So it actually means that AI progress will be even bigger, probably, you know, than expected. Because now, basically, NVIDIA has to mobilize so much of its manufacturing supply chains to provide the GPUs for the AI data centers that now it cannot serve the gamers anymore because you know the gamers GPUs are just not expensive enough and the AI data centers are selling like crazy. So it's just Nvidia saying that they are just prioritizing shipping the GPUs to the AI data centers instead of shipping them to the gamers. Yeah, but no new computing chips also mean it will be more current data centers GPUs instead of new, more powerful chips for data center GPUs. No, no, no. It's only for the gamers GPUs. This announcement is not for the data centers GPUs. The data centers GPUs will keep improving and keep shipping. Here, NVIDIA is talking about the gamers GPUs. Like the data centers GPUs and the gamers GPUs are not the same. It's not the same kind of GPUs. Like the data centers GPUs are selling for like 400,000. Like for example, the H100 is a no, GPU is a data center GPU. This, for example, is the kind of GPU that NVIDIA is going to continue manufacturing, and they are probably going to release more new models, right? But because these new models of data center GPUs are taking all the supply chains and they are selling for so much money, so much more money than the gamers GPUs, they're just going to focus on shipping that and not on and that's why you will not have more 5090 or 6090 or something. These are not put into data centers. These are mostly put into desktop computers for consumers. So yeah, I mean, so basically, Nvidia is just like fucking the gamers in the ass, basically, because it means that if you want the newest and brightest GPU in 2026, you will have to pay the crazy amounts that the data centers are paying. Like an H100 GPU costs like, last time I checked, it costs $40,000. Like this is crazy stuff. Voila. H100. If you want to buy one, not two, not three, not four, one. 72,000 euros, which is like $80,000, right? And there's no stock, of course. So yeah, they just want to. So of course, when they sell H100s instead of a 5090, they make way more money, right? So they're just telling the gamers, sorry guys, but we're just in it for the money. We're going to just sell those instead of the 5090 or the 6090, right? So yeah, that's basically why. Well, it will not be like that forever, right? I hope. It's just that now a lot of the AI data centers need to go online in the next 2 years. Hello. Hello, Bubutsues. Thanks for the follow. A lot of new AI data centers need to go online in the next 2 years. And so there's not enough manufacturing capacity to deliver all these GPUs. So they have to literally stop producing anything else if they want to fulfill these orders, I guess. Yeah, but they're making sense from gaming in comparison to billions from AI. So it's understandable from core perspective. Of course, it's totally understandable. From a purely financial perspective, yeah. And also, it's not absurd either because people are actually using AI, right? Like most programmers nowadays use AI to code their stuff. People are using ChatGPT pretty often too. So yeah, it's like it's real, right? And unfortunately, because there's a big bulge of demand right now, that will not be forever. That is probably a temporary adjustment, right, to the new tech. Well, yeah, for 1 or 2 years will be the gaming GPU will be a bit dry, but I guess it will come back to normal after. Usually, new GPU architectures like 20x or 40x premiered along with new data centers architecture GPUs. Guess now it will be only data center ones. Yes, exactly. That's exactly that. That's exactly it. Yeah. I think at least for the next 2 years, right? Because of course, once the big AI data centers have been built, well, it will go into maintenance mode, right? Or regular replacement or whatever. But it will be more, cruise speed, right? But since right now, all these big tech companies have to build entirely new AI data centers. Yeah, they're just sucking out all the blood from from the GPU manufacturing chain, unfortunately. And yeah. So yeah, gamers will just have to suck it up for now, because yeah, next 2 years, I will make very I will pet my 2080 of my current machine very nicely, until to please not die, because yeah. Even though I think Jensen once said that maybe they will resurrect, or they will maybe continue producing like old GPU, like 3060 or something, or maybe the 4060, or like the previous generations. So, well, Icelandic stocks are printing money though. Nvidia sucks ass though. Already the Nvidia stocks are plummeting. I mean, yeah, and I think the Nvidia stocks are plummeting because on the horizon there's the FPGA guys that are also making inference GPUs now. Yeah, I mean, well, it's not crashing, but it's stalling at least, right? Compared to a few months ago. Yeah. Yeah, because at the same time, like Nvidia is helping build all these new AI data centers like crazy, but they are also like, and it's going to be one of my tech news. So we will talk about this in a few moments. But yeah, I just want to end up with yeah, be careful with OpenClaw. If you use OpenClaw, just isolate it correctly. Don't let it have unlimited internet access, and check what it does on the computer, because maybe a malicious link can just, well, I guess this thing has been mitigated already, but I'm sure there's other weird things going on. Next topic. Attends, let's just go straight to what we were talking here. The series. So for example, Cerebras and other like Grok 2 is one of the startups right now who are actually starting to compete with Nvidia, and I think that's why Nvidia stocks is like stalling a bit right now. Because basically now Nvidia has some, especially for the AI workloads, now it has competition from these AI chip makers like Cerebras. Grok also was one of them. It was bought out by Nvidia, kind of. And what they do is they actually create, custom FPGA chips. So it's like, custom chips that are better at running certain algorithms, and you can just, manufacture them this way. And so basically what they do is they just do FPGA chips to run machine learning inference, LLM inference workloads, basically. So it allows them to make the LLMs run faster and cheaper in terms of energy and whatever. And this is, because NVIDIA GPUs are by definition general purpose, right? You can do whatever you want with the NVIDIA GPU. You can game on it. You can, run an LLM on it. You can train an LLM. You can run an LLM, right? So it's general purpose. These new chips by Cerebras and other ones like Positron also right now, right? Series B, voila, to take on NVIDIA's AI chips. Yeah, it's all about FPGA custom chips, basically, that are specialized chips that can only run a certain kind of algorithm, such as, I guess, the training algorithms or the inference algorithms, and they are just faster at doing that and cheaper in electricity than the NVIDIA chips. So, I think that's why Nvidia is a bit scrambling to buy all these guys first, like they did with Grok, and they also Nvidia is a bit scrambling to also do their own, I think, custom chips, custom AI chips that are not general purpose, just to undercut these guys, I think. Did Nvidia want to monopolize the AI by publishing some framework library that work only on Nvidia chips, something like DirectX for AI? Yeah, so they have CUDA. They have CUDA, right? CUDA is the is the framework that NVIDIA uses, and lots of people use it for training LLMs, basically. Yeah, but at the same time, I'm sure that these guys can just build a chip that just uses CUDA as a base, and maybe they, I don't know how they do it because it's very, very technical, and I guess most of it might be even a bit secretive. Uh, you know? So yeah, the company claims its first generation chip, Atlas, manufactured in Arizona, next to TSMC's probably, Arizona in the factory. I'm wondering. Can match the performance of an NVIDIA H100 GPU for less than a third of the power. That's it, right? And since these AI data centers are just eating a tremendous amount of power, that's pretty good. Positron is focused on inference, computing need to run AI models for real-world application rather than training large language models, positioning the company well as demand surges for inference hardware as businesses increasingly shift focus from building large models to deploying them at scale. That's right. Yeah, so Positron, Cerebras, all these guys, they're just, yeah. It's funny. Nvidia now has some competition, finally, right? Yeah, but I believe they wanted to do separate CUDA just for AI. Yeah, but like they, when people make new chips like that, um, at the end of the day, training an LLM is just some matrix multiplication and running it too, like, so you just need to have good researchers that know how the sausage is made, to make something that still works, right? um I'm sure there's a lot of very smart people that can just reverse engineer a number of these things, and maybe they don't even need CUDA, because CUDA, like the NVIDIA GPUs, is general purpose. You can do anything you want with CUDA. Like you can use a compute shader with CUDA. You can run you can train LLMs. You can run, right? But of course, those chips, I guess, will come with their own little framework that is very way more specialized and don't need to be as gigantic as CUDA is, right? And so then, voila, it will be able to compete. Yeah, I've done some matrix multiplication and transformation university. Maybe I am a LLM. Yes, if you've done matrix multiplication, you are an LLM. Exactly. That's exactly that, Nitro. And I also wanted to check this. The EU says that TikTok must disable addictive features like infinite scroll and fix its recommendation engine. It's funny, so it's not only X that is being burned by the EU. It's also TikTok, which is not very surprising, of course. But yeah, it's funny how in Europe actually the states are starting to become way 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 more inquisitive about the social media, more than they had been before. And like now in France and in the UK, there like some age checks are like ID based age checks are being deployed on lots of websites, but all the porn websites have age checks now in the UK, in France, I guess in other European countries too. And now on the social media, now France wants to ban it. It's not there yet, but France wants to ban social media for children under 15. Until now it was 13, I think. Now it will be under 15. And now the European Commission is talking about TikTok too. Interesting, like how funnily enough, like at the same time that X and Musk and Trump are starting to annoy more the EU about lots of things related to the American companies, the EU is now also increasing the pressure on the American companies. I'm not sure, like, if this is if it's just yeah, like, both sides are getting more aggressive on their own, funnily enough. I'm not sure if it's a tit for tat or if it's just like, the atmosphere of the day. I'm not sure. Chad EU. Most of the EU wants to ban it. They did it in Australia already, I think. Really? Ban TikTok? I mean, I'm not sure if they want to ban, or at least they want to ban it for, voila, the age, for young children or preteens, I guess. But even in the US, actually, 24 states have so far enacted age verification laws. Yeah, so it's a thing that's happening all around the West, actually, not just in Europe. France, Canada, Denmark, Italy, and Norway. Yeah. The UK and Spain are reportedly looking into similar measures. Yeah, okay. Users under 16, yeah. In France, it will be under 15. But yeah, interesting, right? And it all has come like in the everything has started to crystallize in the last 6 months, right? Or at least since Trump came to power. It's funny how these things work, even though I guess it was already a preoccupation before, because TikTok is not like crazy young either, right? So it's funny. All social media below 16 euro. I also saw a user complaining that Steam wanted their ID to verify the account owner age. Oh, really? Steam is also doing that now? Interesting. Interesting. Yeah. I mean, yeah, I guess it's it will probably become a thing. And it makes sense that like at some point governments are catching up to the digital space, and so of course, yeah, they just want like for example in France right now you have now a digital identity like certified cryptographically validated that you can have on your phone to log in to government services, and you need to go to like your closest town hall or whatever of your city, and you can get your identity validate like cryptographically validated inside the government's app on your phone, so that you can do governmental services or whatever easier, and I think it's pretty cool. It's pretty cool. And I guess it can also in a way authenticate, if maybe you will be able to authenticate your age with this app, right? Because it's been validated with your ID card into a real physical government building, right? Like that will have to check like, okay, is it really you? And then since you have the cryptographically authenticated signature, you can use it to prove that you are you. So yeah, I mean, at some point, I guess it was bound to happen. Gonkar, everything good? I'm tuned, but can't be always watching. Yeah, okay, don't worry, Gonkar. It's okay. I just do a stream early today because I can't do one tonight. I think they did it some time ago in Poland and Germany too. You can validate with your bank account. Okay. Yeah. Yeah. I mean, yeah. And in like to a point, but even though you know, I hope that the government manages all this responsibly, and I hope my IDs are not getting leaked to the random Russian forum, hacker Russian forum, at some point in the future, of course, like it often happens with these kinds of services. At some point, I guess this is reasonable to have some form of cryptographic, signature that can authenticate your citizen identity, right? That is valid, where you go, the same way you do when you buy an apartment, when you marry, right? Like you do that, right? You go to your government building and you ask, hey, I am me. Here is my ID card. I was born at no in this city. They have a record of me. I'm real, right? Please officially register that I have been married. I have been buying this apartment. You know, and so it's just that right now it's mostly a paper trail. I know it's a paper thing. I mean, now it's been digitalized, of course. But of course, it is being digitalized on the government side. It can also be digitalized with on the citizen side, right? And it doesn't have to be riddled with bugs. Especially, if they do it correctly, they can just use cryptographic signatures, and if they do it correctly, it can work. So yeah, I mean, I'm actually fairly. I'm not alarmed by this. So some privacy people, are losing their mind, like, oh my god, this is a surveillance state, oh my god. I mean, No, it's just that, yeah, like the laws have to be respected, you know, at some point. You can't just have the internet as the Wild West forever. And yeah, you know, like it's just that as long as the laws are being crafted by democratic processes, right? Where, you know, random people, I mean random people, you know, like all everyone can vote on electing the people who will make the laws. I think this is okay. You know, they will make, like, you know, for example, the age restriction for social media for young people, I think is actually reasonable, right? It's not crazy. Yeah, like when you're 15, you know, especially like between 12 and 15, 16 year olds, like children are experiencing the worst of the human species, you know, in middle school, right? Like the humans between 12 and 16 year olds, and we have all experienced this, right, in our own middle school, I guess, right? They're the worst at this age, right? Like they are mean, they are mocking, they are, uh they start to have these sexual desires that are manifesting themselves, and they don't know how to control. uh they like to be, they become rebellious. They are very group oriented, they become very social, when you become 18. And people can be mocked. People, like in my middle schools, I've heard horrible stories, even just in my little town. So I was in Guadeloupe. It's like a small a French island in the Caribbean, and I remember hearing the stories of what happened in this other middle school, like, at recess, right? Like two or three, 13-year-old guys stripping naked a 13-year-old girl, in at recess. Like weird shit like that only like teens and preteens are capable of, because they're just crazy, right? They are not real structured human adults yet. They're not children anymore, but they're just, and so this middle school period is just the worst to experience as a human with other humans. So yeah, I mean, I guess regular middle school is bad enough for the average 13-year-old. Then they don't need to add on top of that, the multiplication aspect of social media, right? Of course, like I think this is reasonable actually, especially since, yeah, like children are just nasty sometimes. They're just very mean with each other, and the teenagers even more than the regular children. So yeah. Ah, seven streams streak. Gonkal, nice. Surveillance state is unfortunately a byproduct of that, but I don't know if there's another option. Yes, yes. I mean, it's just that, look, at the same time, it's not like the citizens are completely deprived of any, we are not in China. And even in China, they can still use some things to escape the surveillance. Like today we have, bon, voilà, even though in the West there's no point in using that very much, but we have blockchain systems, right? Like so we can still exchange money outside of the state controlled system. Well, even though Bitcoin, for example, is monitored, of course, because it's a public chain, but we have peer-to-peer stuff. Everything that is peer-to-peer, by definition, it's less it's less it's less possible, and the blockchain is uncensorable, except if you use Monero, I guess. Now if you use Monero, nobody can know you. What you do. But yeah, we don't anymore. Bitcoin has crashed and it will never recover. Panic, sell it now. Well, no, I mean, I don't know for how long you've been looking at Bitcoin, but I've been looking at Bitcoin since 2016. it always recovers. You know, it always crashes and it always recovers. You know, for the last since Bitcoin has existed, every few like every 3 to 4 years, basically, Bitcoin loses 80% of its value and then go back up at some point. You know, it's always cycles of like 3 to 4 years, basically. You know, goes up, it crashes 80%, then it's slowly trends back up, and then it explodes, and then it recrashes. It's always the same. So Bitcoin is crashing. Bitcoin is probably going to continue to crash, but will it recover at some point? Yes. Will it go higher than the last highest price at some point in the future in the next few years? Yes. As always, you know. The Bitcoin supply is finite, so yeah. Bitcoin supply is finite, and the fiduciary money supply is infinite and always growing. So, you know, mechanically, Bitcoin will go up over the long term. Of course, short term, it goes up, it crashes, it goes up, it crashes. You know, but yeah. Not this time. It's over panic sell everything right now. Yeah, like all the last times. You know, the last time it was also over its panic sell. Yeah, every time. You know, every time it's always the last time that Bitcoin. You know, after this one, Bitcoin is done. Of course, every time. Every time. Every time. I've heard that in 2018. I've heard that in 2021 or 2022. People will say it again this year, maybe. You know, and then in 2 years, when it will start going back up, people will be like, "Oh, it's back!" Yeah. But isn't it actually infinite in supply? No, it's not infinite in supply. There will there will never be more than 21 million Bitcoin. You can always add another decimal point and trade 0.001 instead of 0.001 Bitcoin. Well, no, actually, there is a limit. I think the limit is like the smallest unit is a Satoshi. Unit. And voila, this is the smallest unit of Bitcoin. So there is a limit in the smallest unit, and there is also a limit in the maximum amount of Bitcoin in circulation, because basically roughly every like 2 years, the amount of new Bitcoins created by the mining nodes get every 7 minutes gets halved, gets divided by 2. So I'm not sure what is the current mining reward current BTC. Reward per block. Yes, right now the reward per block is 3.125 Bitcoin. Voilà. But I guess in 1 or 2 years, it will be divided by 2. And in 2 years after that, it will be divided by 2 again. And in 2 years from that, it will be divided by 2 again, you know? Until in like 2106 or something, if I'm correct, if I remember correctly, then the mining reward for the block will be 0. And then it means that the maximum supply of Bitcoin will stay at 21 million Bitcoin. Yeah, that's how it works. Current BTC in circulation. Yeah, and so right now, already like at the current, like today, there's been 19 million, so roughly 20 million BTC that have been mined from the blocks. And between now and 2100, there will only be 1 million more BTC that will be mined, you know? And then it stops. So yeah, that's just how it is. So no, Bitcoin supply has been crafted to be inherently limited. And that's why the price over the long term is always bound to go up, at least as long as the fiat money currencies continue to be produced infinitely, like they are, you know, like what they've always been doing, you know. So yeah, there will be vibe coding in Neovim in today's stream. No, I think I will quit after the tech news. Yeah, because I have other things to do too before my what I need to do tonight. So yeah. Next topic. Ah wait, new research from DARPA that I thought was interesting. I've been hearing more and more that photonics and light related, like, you know, light computing in a way, seems to be like a new kind of tech that might be interesting, you know, especially compared to like quantum computing, who is always a bit far away. Photonic computing seems to be a new thing that, you know, people are working on and achieving new things with. That's interesting. Photonics chips promise massive speed and efficiency advantages over electronics, but those benefits evaporate in real-world systems because today's photonic circuits are too limited in scale and complexity. That forces constant conversion back to electronics that add milliseconds of delay to systems measured in nanoseconds. The so the DARPA, a new Picasso programs, aims to break through that bottleneck by developing fundamentally new circuit architectures that can perform far more processing in the optical domain, DARPA said in a Thursday notice to release the solicitation. DARPA plans to award several other transaction authority contracts worth up to 35 million each to develop photonic circuits that can handle more computing than the limited current photonic circuits. Today's photonic circuits typically are limited to between 10 and 20 components that perform isolated functions. While these circuits can process data in nanoseconds, systems must continuously convert optical signals to electrical signals for most processings. That adds milliseconds of latency and wipes out any advantages photonic circuits bring in terms of speed, bandwidth, and energy efficiency. So right now the photonics are useful in themselves, but they would need to be like vertically integrated in a way. The entire system needs to be photonics for the photonics to be worth it. Interesting. So it's not retrocompatible with the electronics, which is a bit annoying, but interesting. Quantum computing breakthrough, IBM, Google, please go up. Yeah. You know, I have seen recently some physicians saying that quantum computing has like still big fundamental problems that might not be able to be solved. Bon, I guess, you know, physicists are being proven wrong all the time. But it's interesting because I've never heard of that. Like, I've never heard physicists saying, "Oh yeah, quantum computing is never going to work in a million years because this is impossible to solve or whatever." Interesting. DARPA is looking for circuit-level improvements rather than improve individual components. The agency wants teams to create perfect photonic circuits with imperfect components. The program has two 18-month phases. Phase 1 will focus developing circuit level strategies to preserve optical signal integrity and suppress problems caused by reflections, signal leakage, and crosstalk across photonic circuits. Mm. Yeah, so what they do, I guess, is just like they're just using like electronic scale mirrors, right? And lasers, I guess. It's funny. Yeah. Phase 2 will focus on generalizing those approaches to achieve distinct circuit functionality. Proposals must address both phases. DARPA will make a down-select phase 1 and phase 2. DARPA has a strong preference for US-based manufacturing of the photonic circuits. Any use on non-US manufacturing must include an explanation on why an equivalent domestic capability is not available. All photonic circuits developed under the program will be delivered to a government-designated design repository. DARPA requires at minimum government purposes rights to intellectual property developed under the program. Interesting, right? I feel if there is like an alternative to the current, like an interesting new paradigm for electronics, you know, that is, I guess, similar to quantum computing, but actually more achievable, like, you know, and it's just a matter of engineering basically rather than, you know, real physics breakthroughs or whatever. It might be photonic computing, you know, because people like I've read a bunch of articles that basically say that, yeah, if only photonic computing was like, you know, fully developed with like full supply chains or whatever, it would be better than the current electronics. um it's just that it's not the case yet. We don't have, you know, for photonic electronics or whatever, photonic computing factories, right? It's most still in the labs. But you know, I'm sure, like, if I'm sure in the next 10-20 years, some of these researchers will come out of the lab, start to manufacture some big factory of photonic chips or whatever for certain applications, you know? And one of these will just become rich because of that, you know? Maybe it's the next paradigm of electronics is actually photonic computing, not electronics. But the problem is that it's not retrocompatible with electronics, or at least the benefit gets erased if you make it retrocompatible. But it's still interesting if you just have like a fully vertically integrated system that is based on photonic computing. You know, you could make something that is actually, you know, a new breakthrough, basically, technological breakthrough. Interesting. And also talking about the quantum computing, though, it's the same with the chips technology. We're like on the verge of breaking physics. We're making 3 nanometer chips, and 2 nanometer chips aren't physically possible because the electric charge is too big to follow the routes. Yes, I mean, you know, maybe when if we hit if the nanometer wall of the electronic chips is real and they don't find a way around it, right? Like they do sometimes. Maybe people will look at photonic chips as the next, you know, the next wave of computing technological innovation, I guess. Or at least it could be a good contender, you know, because we know that quantum computing will not actually replace traditional electronics, because quantum computing, you know, it's only practical at very specific kinds of algorithms. So at most, quantum computers will just, if it works, there will just be some form of big GPU, to do certain kinds of algorithms, the same ways, the same way the GPUs are better at certain kinds of algorithms, like matrix multiplications, right? Uh, so that's what the best case for quantum computers is. But when it comes to a real leap in capability in terms of computing, right now, looking around, the photonic computing seems to be the next potential leap that we could do. So yeah, that's interesting. What do you mean by electric charge be too big? I'm not that good at electronics. Yeah, it's just that when you get too small, yeah, in electronics you send electricity along paths. Paths are becoming too small and too close together. The electric signal is too fat. Can't follow basically. Yeah, it's just that at some point the chips get so small than the atoms themselves and their inherent quantum unstable quantum state or whatever from quantum physics start to manifest, and then the electrical charges and the logic gates don't work anymore because the instability of the quantum scale or whatever manifests too much, whereas at the macro scale it's more stable. But as the chips get smaller, now they get to interact with this quantum physics kinds of phenomenons, and that fucks up the logic gates and how the electron go through the circuit basically. You mean the electron? Yeah, the electrons. Yeah. Getting attract abstract and influence the logic. Yeah, it's just that at some point when the chips get too small and when a logic gate is only a few atoms wide, you know some stuff don't work anymore basically, because when you go too when you go too low, the quant as I recall, I'm not an expert at this, but as I recall, when you go small enough into the electronics, quantum phenomenons that make the electrons place a probability or whatever, it's not fixed like in macro environment, it's more fuzzy. And so at some point, if you go low enough, the electron's positions is fuzzy enough that your logic gates and your transistors basically don't work anymore if you go down, down enough. Voilà. Attracted, yeah, I mean all kinds of stuff I guess can happen. I'm not sure about the exact quantum phenomenon that fucks up the transistors when they are made too small, but yeah, that's what people say it will happen and probably starts to happen already. I'm not sure. A clever quantum trick brings practical quantum computers closer. ETH Zurich. Quantum computers struggle because their qubits are incredibly easy to disrupt, especially during calculations. A new experiment shows how to perform quantum operations while continuously fixing errors, rather than pausing protection to compute. The team used a method called lattice surgery to split a protected qubits into two entangled ones without losing control. This breakthrough moves quantum machines closer to scaling up into something truly powerful. I love to be a quantum scientist. Imagine going to work and working breaking fabric of space and time. Yeah, I mean, yeah, it might be interesting. protecting information with logical qubits, fixing errors. Well, this is very technical stuff, so I'm not sure I need to read this just to know what's going on. Alors, one could say the end result of this operation was that we had two logical qubits entangled with each other. During the splitting process, bit flip errors continued to be corrected. Afterward, bit flip errors correction resumed independently on each half. While this operation does not yet produce a controlled NOT gate on its own, it can be combined with additional splitting and merging steps to create one. One could say that the lattice surgery operation is the operation and all of the others can be constructed from it. He adds, to the best of our knowledge, this is the first time lattice surgery has been performed on superconducting qubits. And we still have some way to go. For instance, 41 physical qubits would be required to make the splitting operation on one logical qubit stable against phase flips 2. Nonetheless, this demonstration of lattice surgery on superconducting qubits marks an important step towards the ambitious goal of building useful quantum computers with thousands of qubits. Yeah, because right now, I guess, like, if I recall correctly, yeah, these like quantum computers have a problem of like stability because they have a problem with their qubits, flipping or whatever. Voilà, decoherence. Voilà, they have the quantum computers of today have a problem with decoherence. Okay, one of the biggest challenges come from decoherence, a process that introduces errors into quantum systems. These errors usually take the form of bit flips or phase flips. A bit flip occurs when the qubit unexpectedly switches between 0 and 1. Scientists perform surgery on a grape. Yes, exactly. A phase flip happens when the phase of a quantum superposition suddenly reverses, changing from positive to negative, which is a problem, of course, in a computer, right? When you want the zeros and the one to stay zeros or ones, you don't want them to randomly flip. Yeah. So I guess they are solving that. They are solving the decoherence. Or this really weird, algorithm that they try to run on it. Yeah. I mean, the annoying thing about the quantum computers is that they don't seem to actually be useful yet, at least for algorithms that are actually useful in electronics, in computing, like for example the algorithm that Google used for to claim quantum supremacy or whatever. Like it's mainly a big mathematical problem, but it's not actually useful in any real computing workload, basically. So it's interesting, right? I just hope that at some point we will actually be able to use it, even within a research lab, right? For actually useful electronic things, because otherwise, and even if it's just useful for like very complex physics, scientific physics calculations or whatever, that would still be good. But I guess right now they've not shown anything like that. No? So well, I hope they get it. But also I'm wondering how much of these more useful algorithms might be founded, like might be accessible only with a system that doesn't have as much decoherence, right? I guess maybe if they fix the decoherence, maybe a wider array of algorithms will be accessible now. I'm not sure. Because I guess if you have like literally a random bit flips that happen in your calculations, I guess most calculations are getting fucked up in a big way by this, right? Uh, so yeah, but that's my own, reflections. I'm not sure, but yeah, I'm always, watching a little bit what's happening on the computing. Our computers run on 0 and 1s. Just make them run on 0, 1, and 2. It will be 50% faster. Exactly. That's all right, Nitro. You are so right. It's just easy, It's just easy. It's just easy. The process becomes more complex when researchers want to apply a logical operation such as controlled NOT gate between two logical qubits. Errors can occur during the operation itself, and those errors must also be corrected. Performing a logical operation in this fault-tolerant way would be relatively easy if we could move our qubits around and connect them arbitrarily to each other. In superconducting quantum processors, however, qubits are fixed in place. Only neighboring qubits can interact, which limits how operations can be carried out. Bon. It's really scientific jargon here. Explain for a beginner what they did here. Researchers find a way to make quantum computers more stable. Normally, quantum are very fragile. Yeah, okay. To do calculations without pausing to fix errors, which brings us closer to having powerful, error-free quantum computers. Yeah, cool. Okay. Quantum computers are getting better. And I'm done here. Basically, on enter, it can randomly flip. The logic gate may randomly fit from not to or, and, etc. And the output may also randomly flip. I mean, yeah, that's a problem, huh? If you want to do calculations, yeah. I mean, that's just called, like, in traditional computing, it's called data corruption, right? So it's pretty bad. You can't do much with when everything is corrupted, right? So yeah, quantum computers. Well, at least now they're getting less corrupted, right? They're more and more getting less corrupted, which is a good news, I guess. Yeah. But I think I'm going to leave now. Do you have? Oh wait. Up. Do you have? I just want to check something really quick. Did people watch my video? If you have something to tell me, now is the time. Thanks for the stream. Thanks for the insight. Yeah, thank you, Gokar. Hey, look, I have no, 20 in my clips. Look, I have 17 subscribers on my clips. 5K views. It's pretty cool. Bon, my traditional videos are not getting any views. Oh, they're getting a few views now. Before it was 0, now it's 3. Pretty good. But look, it's mostly my short. I guess I'm going to just post shorts nowadays. Because I'm not sure, like, I guess people don't watch these. People are just watching the shorts. Big YouTuber, yeah, soon. Look, 300 views. It was posted 2 days ago. The shorts are just getting the views. And so, you know, the funniest thing is that these, well, I have stopped making thumbnails just because it's long and annoying, and the result is not, you know, crazy good. And it's the same exact clips, right? It's the same cutting, it's the same editing, but the short just get higher things. I guess maybe so. Maybe for the short clips under 3 minutes, I need to put that as a short, and maybe for the long video, I need long clips, like, you know, the full 20 minutes or 30 minutes clips or something. I'm not sure, and I'm not sure if I need to do a thumbnail. But I'm still not sure about everything. Will become next pirate software guy. Well, look, I'm not becoming pirate software in terms of um, ego and in terms of drama. Okay, even though I could just, you know, I could just say, okay, chat, it's very simple. Okay, you have one box. You know, I just go on Excalibur like this. You know, okay, guys, it's very simple. Okay, you have one box like this. Okay, and then what you need to do is you just need to go into this other box. Okay, now this is a wrong box. Now this is a good box. Thank you, guys. I hope you got my advice here. Thank you very much. You know, life is simple. Development is so simple, guys. You know, no, you just need to avoid this box, and you need to go into this box instead. It's easy, okay? It's so easy, guys. So easy. So easy. Okay. Voilà. Wait, so what was I? Uh, yeah, I need to have. I guess the shorts I will continue. You know, not no pirate software. He got very popular just from posting shorts. Yeah, once people started watching him, the drama started long lore. Yeah, yeah. So he's a game dev. He's a game dev streamer, and he made a lot of views with the shorts. You know, but I understand why now, because, you know, my clips are getting like 100 times the views from 0 to a few hundreds, you know, with the shorts. So I can understand why he did that. Like, I mean, I guess, yeah. It's just that I'm wondering if maybe for this to take off, you need to have like already enough of a, I don't know, an audience. I don't know. Or maybe the algo is just fucked up with these. Or maybe people just don't click because I don't know. I don't have the good thumbnails, the good titles, the good reach. At some point I did a lot of, like, you know, A/B testing with the thumbnails and the titles, but it didn't do anything. Except from this one, where I got 64 views. Wow. But most of the other ones, it doesn't change anything. When I don't do the A/B test, it's the same. So, bon. When I have like slightly longer, maybe I should try posting like a very long clip, like, you know, a 30-minute clip with the horizontal one. It's just that it's very annoying to render. It will take me like 2 hours to render 30-minute clips. But yeah, shorts are working, you know. So I guess I continue doing that. Paste. Also, I'm wondering if now maybe YouTube, because all the short stuff is in the shorts, maybe if they see like, you know, traditional videos that are not well edited, well mounted, you know, videos or something, do they actually, because I guess that YouTube now has algorithms to analyze how a video is mounted or something, I guess, right? So maybe when it's not mounted, it might just not propose it to anyone. I'm going to try stuff, I think. Because I want to do fully edited videos, like, you know, tutorials and, you know, tutorials to NeoVim, LazyVim, Cloud Code tutorials, just also just for me to go deep into all the little features. Um, but yeah, maybe those work better, you know. We'll see you Tuesday, right? Yes, see you next Tuesday. Exactly, next Tuesday. Yeah, next Tuesday. Exactly. Next Tuesday at the normal hour. Yeah, exactly. That's right. So yeah, see you everyone. I am leaving now. Bye bye. Bye 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 bye.